Now when we're thinking about the ECG or the EKG, it's exactly the same thing. We need to consider the P, Q, R, S and the T waves. But it's good to know precisely what each wave is and what it represents. So here we have the isoelectric line. Now what I've drawn here is an isoelectric line. Iso means the same. So the electrical activity along this line is the same. That's the isoelectric line. And here we have the ECG tracing the isoelectric line. Now the first thing that's going to happen is there's going to be a P wave. And the P wave is the upward deflection away from the isoelectric line and the downward reflection back towards the isoelectric line. So everything I've drawn there is all P wave. That's all P wave. And we know the P wave is representing the electrical activity as detected on the surface of the body as a result of atrial myocardial depolarization. Then things are going to go along for a little while. Again, returning to the isoelectric line. And then the next thing is going to be the Q wave. And the Q wave is the deflection down from the isoelectric line and the deflection back up to the isoelectric line. So the Q wave is everything I've drawn there in yellow. Then the R wave is going to carry on up away from the isoelectric line, and it's going to fall back down to the isoelectric line. So here we have the R wave in red. So we see the R wave has an upward deflection and it has a downward deflection. So that's PQR. The next wave is going to be the S wave, and the S wave is the deflection below the isoelectric line and back up to the isoelectric line that occurs after the R wave. So P, Q, R, that's the S. So everything I've drawn there in blue, the downward deflection and the upward deflection, that is the S wave. And then we're going to return to the isoelectric line for a period of time. And then the next wave we're going to see is going to be the QRST wave. So here we have the T wave I'm drawing in pink. And again we see the T wave has an upward deflection away from the isoelectric line and a downward deflection back to the isoelectric line. And then we carry on before we come to the next P wave. So the P wave, the electrical activity as detected on the surface of the body as a result of depolarization of the atrial myocardium. The whole QRS complex is the electrical activity as detected on the surface of the body as a result of depolarization of the ventricular myocardium. It's a much bigger wave because the ventricular myocardial mass is much greater. And then the T wave is the electrical activity as detected on the surface of the body that occurs as a result of ventricular myocardial repolarization. So this is the repolarization wave. Now there is a repolarization after the P wave, but we don't see it because it's buried in the QRS complex. It is inside the QRS complex. Now the depolarization of the atrial myocardium is essential because this is what stimulates atrial contraction. It is the depolarization of the muscle that stimulates its contraction. So the atrial will start contracting there, up to there. That is the atrial contraction that occurs as a result of the depolarization of the atrial myocardium. So remember, the depolarization is what triggers off or causes the contraction of the relevant part of the myocardium. And then there's going to be ventricular contraction, and that's going to start there, go up to about here. So this is ventricular contraction. And the ventricular contraction here is occurring because it's been stimulated by the ventricular myocardial depolarization. So in health, these are the same. The P wave is what stimulates the atrial contraction, the QRS, the ventricular contraction.